Somewhere in America, you're sitting in traffic. Meanwhile, in China, a pilotless bus just completed its 17th millionth ride. A vacuum train hit 700 kilometers per hour, and a two-seat flying taxi received the world's first commercial license to carry passengers through city skies. No, it isn't science fiction. This is happening right now. Operational, carrying real people. Today, I'm breaking down 7 Chinese transport systems that are so far ahead of anything operating in the United States that calling it a competition almost feels generous. And I'm telling you right now, when you reach number 1, you'll understand why some experts believe America may have already lost the transport race of the 21st century. Subscribe, because this gap is only getting wider. Number 7. Changjiang Sansha 1 Electric Cruise Ship. This is the world's largest all-electric cruise ship, and it's doing something American shipyards have barely attempted, moving 1,300 passengers at a time with zero emissions. 1,300. That's still more than 2 fully loaded Boeing 737s crossing the water on battery power alone. How is this even possible at that scale? The key lies in a massive lithium iron phosphate battery bank generating 7.5 megawatt-hours of capacity. That's roughly the equivalent of 100 electric vehicles packed into the hull. The system recharges at port using shore power in as little as 6 hours, enabling the vessel to sail up to 100 kilometers per charge without burning a single drop of fuel. What's most impressive isn't the technology itself, it's the deployment. The Changjiang Sansha 1 isn't sitting in a shipyard waiting for permits. It launched in March 2022. It's operational, carrying tourists, cutting emissions across one of China's busiest waterways, the Yangtze River Reservoir System, while American ferry operators are still debating whether electric propulsion is viable. But here's what's truly significant. This ferry is just one vessel in China's electric maritime push. Over 900 electric ships are now operating on Chinese waterways, a fleet that barely existed 5 years ago. And that's only where this list begins. Number 6. CRRC Autonomous Rail Transit. We have something that's quietly solving a problem American cities have struggled with for decades. How do you build metro-quality transit without metro-level costs? China's answer is the ART, Autonomous Rail Transit, a rubber-tired smart tram that follows virtual tracks painted on ordinary roads. The flagship deployment runs 17.7 kilometers through the city of Yibin, moving 300 passengers per train at speeds matching light rail, but at 1/5 the construction cost of a traditional metro. Let that sink in. 1/5. How do they pull this off? The ART uses optical sensors and AI navigation to follow dashed lines on the pavement. Trains run on battery power, recharging at stations in under 30 seconds using fast contact systems. The entire Yibin line was built and operational in under 3 years. Compare that to American light rail projects that routinely take a decade and billions of dollars, often for less than 20 kilometers of track. But what's truly impressive is the scalability. ART lines are running or under construction in over a dozen Chinese cities. It's not a pilot program, it's becoming standard urban infrastructure. Number 5. Bohai Monster Ground Effect Craft. This is a ground effect craft, also known as a wing-in-ground effect vehicle, or echronoplan. And China just built one of the largest ever constructed. We're talking about an aircraft that flies just meters above the water's surface, exploiting the cushion of compressed air beneath its wings to achieve speeds and fuel efficiency impossible for conventional ships. The images revealed a vessel roughly the size of a Boeing 747 skimming across the Bohai Sea at what analysts estimate is over 300 kilometers per hour, faster than any ferry, more fuel efficient than any cargo plane, and nearly invisible to radar. How does ground effect flight actually work? When a wing flies close to a surface, the air beneath it can't escape downward. This trapped air creates extra lift, meaning the craft can carry enormous payloads while burning far less fuel than aircraft at altitude. The Soviets pioneered this technology in the 1960s, but China has now revived and scaled it.
The strategic significance is massive. A fleet of these craft could transport troops, equipment, or cargo across the Taiwan Strait, the South China Sea, or any contested waterway at triple the speed of ships without requiring runways. If these technologies are already blowing your mind, wait until you see what's coming next. Make sure you're subscribed so you don't miss the remaining 4 breakthroughs, including a train targeting 1,000 kilometers per hour and a vehicle that's already completed more autonomous rides than any competitor on Earth. Number 4. T-Flight Vacuum Maglev. In December 2024, China announced that a crewed test pod had reached 700 kilometers per hour inside a low-pressure tube, the fastest any human has ever traveled in a ground-based maglev system. That's nearly double the operating speed of Japan's famous Shinkansen bullet trains, but that was just the beginning. By July 2025, Chinese engineers completed a second test inside a near-vacuum environment, hitting 620 kilometers per hour in conditions that simulate the full-scale system, and their target? 1,000 kilometers per hour, 621 miles per hour, on the ground. To give you perspective, that's faster than a commercial jet at cruising altitude. How is such speed even achievable on land? The key lies in 2 innovations working together. First, superconducting maglev. The train floats on magnetic fields with zero friction from wheels or tracks. Second, the vacuum tube. By removing most of the air, you eliminate the drag that would otherwise tear the vehicle apart at those speeds. China has already constructed multi-kilometer tracks in Shanxi province and is planning a functional Beijing to Shanghai corridor. If completed, that journey, roughly the distance from New York to Chicago, would take just over an hour. America's Hyperloop? Still in concept phase. Virgin Hyperloop laid off most of its staff in 2023. Elon Musk's company pivoted to cars and tunnels. Meanwhile, China is actually bending the curve on ground transportation physics, and they're doing the same thing in the sky.
Number 3. Space Transportation Hypersonic Prototype. In January 2025, the Chinese aerospace firm Space Transportation completed a critical test flight of their prototype at 4 times the speed of sound. That's faster than any bullet ever fired from a handgun. And they're targeting Mach 5 for commercial operations. Beijing to New York in 2 hours. Shanghai to London in 90 minutes. How is any aircraft supposed to survive those conditions? The key lies in advanced thermal protection systems, composite materials capable of withstanding temperatures exceeding 1,500 degrees Celsius at sustained hypersonic speeds. The company has reportedly solved the re-entry heating problem that has plagued American experimental spaceplanes for decades. The vehicle uses a staged launch system. Rocket boosters lift it to the edge of space, where scramjet engines take over for the hypersonic cruise phase. It then glides to a runway landing, just like the space shuttle, but with passengers on board. And that contrast becomes even sharper with our next entry. Number 2. EH216-S Flying Taxi. The world's first commercially licensed autonomous flying taxi. This 2-passenger electric vertical takeoff and landing vehicle, an eVTOL, became the first in history to receive a full commercial air operator certificate. The specs read like science fiction written 20 years ago. Top speed, 130 kilometers per hour. Range, 35 kilometers. 16 independent rotors providing redundancy, meaning even if multiple motors fail, the aircraft lands safely. No pilot, just passengers and an AI flight system. How did EHang convince regulators to approve something this radical? The answer is data. Over 40,000 autonomous test flights logged without fatal incidents. Millions of kilometers of flight data proving system reliability. By mid-2025, EH216-S units were already conducting scheduled demo flights in Shanghai, Shenzhen, and Guangzhou. What about America then? The FAA hasn't certified a single autonomous passenger eVTOL for commercial operations. Joby Aviation and Archer is still in testing phases, years behind.
But the real king of this list isn't flying through the air, it's rolling through 22 cities at ground level. Number 1. Apollo Go Autonomous Robobus Fleet. The Apollo Go Robobus and Robo-Taxi network, operated by Baidu, has now completed over 17 million fully autonomous passenger rides. 17 million rides. Not test loops on closed tracks, not safety driver-supervised demonstrations. Fully driverless Level 4 autonomous vehicles carrying real passengers through real traffic in real Chinese cities. 22 of them and counting. To understand the scale, let's compare directly. Waymo, America's leading autonomous vehicle operator, is completing approximately 150,000 rides per week. Their public target is 1 million rides per week by 2026. Apollo Go is already doing 250,000 rides per week, and they've accumulated over 240 million autonomous kilometers, the largest real-world autonomous driving dataset on Earth. What makes this lead so difficult to close? While American cities debate whether to allow robo-taxis on public streets, Chinese municipalities are designating AV priority zones, building smart road infrastructure, and fast-tracking permits. Baidu went from limited pilot zones in 2020 to 22 city operations in just 5 years. The economic reality is brutal. Autonomous fleets eliminate driver labor costs, typically 40% of ride-hailing expenses. Whoever scales first captures permanent cost advantages. And the final truth is that data is the fuel of autonomy. With 240 million kilometers logged, Apollo's AI has encountered traffic scenarios that Waymo's system may not see for years. China didn't just enter the autonomous vehicle race, they're riding the finish line.
From electric ferries carrying 1,500 passengers to vacuum trains targeting 1,000 kilometers per hour, from ground-effect monsters skimming the Bohai Sea to flying taxis licensed for commercial skies. And at the summit, an autonomous fleet with more rides completed than any competitor in history. This is China's transportation present, and it's accelerating while America debates. So I have to ask you directly, which one of these technologies impressed you most? The hypersonic space plane, promising 2-hour transcontinental flights? The vacuum Maglev that makes bullet trains look slow? Or the 17 million ride robo-bus network that's already proving autonomous transport works at scale? Drop your answer in the comments, and tell me this, do you think America can still catch up? Or has the gap grown too wide?